Okay, so today we're still working on exponents, and our goal is I know what a negative exponent means. Now, we talked a little bit about that yesterday in the video, but we're going to look a little closer at it today. And I can evaluate, in other words, actually do the calculation of expressions that have negative exponents. So before we talk too much about negative exponents, please remember the exponent laws we learned from last class. Okay, they still apply to everything we're doing. Okay, now we know what a power actually means, a repeated multiplication. So 5 cubed, we know that that means 3 5s multiplied together. Okay, but then what happens if I have 5 to the negative 3? What does that mean? Can we have negative 3 5s? Like, how do you have negative 3 5s? It doesn't make kind of sense if we look at it as repeated multiplication. So let's look at a pattern, because the pattern might help us. Okay, so first of all, if we look at the 2 column first. So 2 cubed, we know is the same as 2 3 times, right? And we also know that that's the same as 8. Okay, 2 squared, we know that's 2 times, and we know that is 4. So I'm not going to keep repeating those. Okay, so 2 to the power 1 is 2. And we know 2 to the power 0 is 1. So let's look at this pattern so far. What's happening each time is I'm cutting these in half. 8 divided by 4 is 2. Or 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So if I keep following that pattern, 2 to the negative 1 should be 1 divided by 2. So what is 1 divided by 2? 1 divided by 2, well, I could write it as a fraction, so that would be 1/2. Okay, and what about the next one? What's 1/2 divided by 2? Well, that's the same as 1/2 times 1/2, which is 1/4. And then if I look at 1/4 divided by 2, is the same as 1/4 times 1/2, which is 1/8. So let's take a closer look at another pattern that you should maybe see, and I'll do it in blue. Look here, we have an 8, I have 1/8. I have a 4, I have 1/4. I have a 2, I have 1/2. Okay, so notice 1, 1. Okay, and they're related to each other. The only difference is the 2, 4, and 8 are on the denominator when we have a negative exponent. Now, the same is going to be true if I do the same pattern with 3. So 3 cubed is the same as 27, 9, 3, 1. And you can see each time we're dividing by 3. Okay, so I'm dividing by the base each time. So if I do this, 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. And 1/9 divided by 3, which is the same as not 1/9 times 1/3, by the way, that's 1, is 1/27. So the same pattern happens. Notice the 27, 1/27, 9, 1/9, 3, 1/3. So it still occurs there as well. So what we end up having, we can think of a negative exponent as repeated division. Notice I divide it. Also notice that the value of the negative exponent is just the reciprocal of the corresponding exponent. Okay? So that makes sense, okay? So we were able to determine that by following a pattern rather than repeated multiplication that we learned when we first learned about exponents. Now, the general rule for integer exponents are the following. A to the power 0 equals 1, as long as a is not 0. So in other words, we looked at this before, anything to the power of 0 is 1. A base to the negative exponent is the same as 1 over a to the positive exponent. Okay? So that is true. I could do it the reverse as well. Also, if I have something that's in a bracket, a such as I do here. If I look at this one, a over b to the negative exponent, so what that happens is it flips. There's the reciprocal, b over a. Okay, so it reciprocates it to the positive exponent. All right, so example, evaluate the following, leave your answers as a fraction. Now the reason I tell you to leave it as a fraction, I don't want you to take your calculator and go 2 to the power of negative 5, and it gives you this little tiny wee decimal. I want, it says 2 to the negative 5, that's the same as the reciprocal of 2 to the positive 5. Now, that's simplified with positive exponents, but what is 2 to the 5th? Now I would take my calculator, find 2 to the 5th, which is 32. Okay, so if you took 1 divided by 32, you get that small decimal your calculator gave you. Okay, so that's what I want. It's my answer is left as a fraction. Now, if I look at 4 to the negative 2, the reciprocal of 4 is 1/4 to the positive 2 now. So that's the same as 1/16. And moving right along, 5 to the negative 3, the reciprocal of 5 is 1/5 to the positive 3. Okay, so what I did is evaluate if it were a positive exponent, then take the reciprocal. Okay, so let's look at some more. Again, I'll give us the little hint here. So we're going to take the reciprocal of the fraction, then apply the exponent. Okay, so we're going to take the reciprocal, first of all, of 1/5. The reciprocal of 1/5 is 5. So if I change this to 5, it will be 5 to, it's 5 over 1 actually, to the power of positive 3. So in order to get rid of that negative exponent, I take the reciprocal of the base. So 5 cubed is the same as 125. The next one, 1/2 to the negative 5. So I'm going to take the reciprocal of 1/2 is 2 to the power of positive 5. So this is really 2 to the power of 5, which is 32. The next one, 2/3 to the power of negative 2. So I need to take the reciprocal of 2/3, which is 3 over 2 to the positive 2. Now this requires now for me to bring that 2 into both of those, and so I end up with 3 squared over 2 squared, and because it says evaluate, 3 squared is 9, 2 squared is 4. Okay, so we have that part. So that usually works the best. Okay, so moving on to the next type of examples. Expresses a power with a positive base. Okay, so right now I have really what this is 1 over 32, which is the same as 32 to the negative 1. So we're just working backwards. So if I reciprocate the 1/27th, it would be 27, but because I want them equal, it's going to be to the negative 1. And the same thing here, this would be 10,000 to the negative 1. Next question, example, express each as an exponent with a base of 2. So I have something a little bit different this time. So what I need to do is I need to write the base as a power of 2, then apply the exponent law for a power. And that's what we're going to do, I believe, down here, if I had some more going on here. So what I'm going to do is I want to change 4. So the question is, I want to change 4 so it is 2 to the base of something, to the power of something. So what are we going to change 4 to so this is true? We know that it is true if I have 2 squared. So 2 squared is the same as 4, so I've just replaced the 4 with 2 squared. Power to the power, I need to multiply. So I really end up with 2 to the power of 6. Now the next one, 16 to the negative 6. So again, my brain has to think 16 is the same as 2 to the power of what? Okay, so I'm doing a little bit of guessing there. So when we do that, what we're doing is that's going to be 2 to the power of 4. And then power to the power is 2 to the power of negative 24. And if we do not like the negative, exponent, which I don't, I'm going to flip the base, I'm going to reciprocate it, and so it's really the same as 1/2 to the power of 24. And the final question here is 64. 64 to the power of what equals 2? And hopefully that you realize that that's going to be 6. So now power to a power I multiply, so that's going to be 6 times -3, which is -18. And finally reciprocate 2, so it has 1/2 to the 18th. Okay, so notice what I did is I wrote the base as a power of 2, then I applied that power to a power, in this case law. Okay, so some questions for you to do in the textbook.